Okay, today we're going to do the buggy car lab, and what we're going to do is we're going to take the buggy cars you built and we're going to conduct an experiment. Now, the experiment is this. I'm going to take, here's the level ground, okay? This is like the floor in the room. And what we're going to do is we're going to use the whiteboards that are at your station. Those are going to be your ramps. I'm not going to use this, the plywood as a ramp anymore because it's just too awkward, and there's 6 groups, and have 6 groups trying to use it. It's just too much. So what you're going to do is you're going to take the whiteboard and you're going to tilt it on the ground like this at a certain angle or at a certain height. And what we're going to do is you're going to take your buggy car or your little moon buggy car. I don't know, some of you had cars that look something like this. And you're going to release it. Now, this is an energy class. This is a class on energy. So basically what I want to do is talk to you about the exchange in energy that's going on here when you release this car down the ramp. So you release it. Now, let me ask you this. What force is acting on the car that's going to do work on the car? It's the force of gravity. So now, gravity is going to do work. So what kind of energy does it have up here at the top? Yeah, it has what we call gravitational potential energy. So your car is parked up there, and now what that is, remember, is that's basically the work that gravity, am I still on screen there? Almost, yeah. It's the work that gravity can do. So gravity can do work on this thing. All right. Now, where did that energy come from, by the way? How did the car get this gravitational potential energy? And where did that energy come from? What's that? Yeah, the height. Yeah, the height. Certainly, the gravitational potential energy depends on the height. But actually, the energy. Where did that gravitational potential energy come from? I mean, what's going to happen when we do this lab? You're going to have to put the car there, right? So who's giving it that energy? You are. You're going to pick the car up and put it on that ramp. So that energy came from you. Where did you get that energy? From the food you ate. Where did the food get? Where did the food come from? Where did the food's energy come from? Well, if you go back far enough, it came from solar energy. And where did that energy come from? Where did the solar energy come from? Yeah, the nuclear reactions in the core of the sun. I'm going to say this over and over and over again. Almost all the energy that we use, if you trace it back, the source of that energy was nuclear fusion in the core of our sun. So think about this little car. It's a solar-powered car. Even though there's no solar panels on it, because if you go back far enough, there is solar power involved. Now, we do get some of our electricity that is not from the sun. Anybody know where the energy is that's not from the sun? Geothermal. Yes, geothermal. And what's the other one? Oh, now wind is indirectly from the sun because it's the sun that hits the earth and it evaporates water, and it causes convection and pressure differences in the atmosphere that result in winds. Okay, so wind is actually a form of solar energy. But there is one that comes from the ground. It's very similar to geothermal energy, like you mentioned. It's nuclear fission. We have nuclear power plants like Diablo Canyon that produce electricity for us. That energy did not ultimately come from the sun. It came from the fission of uranium atoms. And we may study the details of that later in the year. But anyway, so the energy that this car has came from the sun. because it came from you, because it came from your food, and the food captured solar energy. All right, so we're going to release this. Now, what happens here is that there is a force of gravity on here. Now, this is a little bit advanced for many of you, but here's what I want you to see. You know that what direction is gravity? Straight down, right? So this is the force of gravity. Now, the force of gravity has another name. What else do we call the force of gravity? No, that's a good guess. Our weight. Yeah, it's measured in newtons. But force of gravity, another word for force of gravity is weight. Weight is the force of gravity. And we're going to talk about that later in detail. But look at this. You see, look. The force of gravity is straight down. So how come this car just doesn't fall straight down if it's on this ramp? Because, beautiful, that's great intuition. There is another force acting on it, and it is the force of the ramp on the car. And it cancels out some of the weight. Now, if you look at the weight as if it's a triangle, watch how I add these arrows. Some of the weight is pulling it down the ramp, and some of the weight is being canceled out by the ramp. So this part of the weight that's perpendicular or at 90 degrees to the ramp is canceling out that part of the weight, but the weight, the part of the weight that's down the ramp isn't being canceled out by the ramp. So this is the force, this part of the weight. Right? It's not all of the weight. It's only a little part, a little part of it. A part of the weight is left over to pull it down the ramp. And so that's going to do work. And remember what we said work is. Work is when we change from one form of energy into another form. So what kind of energy is the car going to have at the bottom of the ramp? So here's the car at the bottom of the ramp. Oof. What kind of energy does it have? It doesn't have gravitational potential energy anymore, at least not compared to the floor. But it's moving, and it has mass. Something that's moving and has mass, can it change the environment? Oh yeah, go out and play on the freeway if you don't believe me that things that are moving. I got hit by a car when I was in high school. I was a pedestrian and got hit by a car. And I found out that cars have mass, and when they're moving, they can do work. They can make changes. They made quite a few changes to me. I lost a lot of skin and bruised, and luckily no broken bones or anything, but I was lucky. Anyway, that's a long story. So what kind of energy does it have because it's moving? We call that kinetic energy. So we're going to have a conversion of from gravitational potential energy to kinetic energy. Now, what happens to your car eventually? It's going to stop, right? It's going to stop. So here it's stopped, which means it doesn't have any energy left. It has no kinetic energy because it's stopped, and it has no gravitational potential energy compared to the floor because it doesn't have any height above it. Gravity can't do any more work on it. Where did all that energy go? It has to go somewhere. You can't just say it disappears. Energy is never created or destroyed, just transformed from one form into another. So where did all that energy go? Yeah, it heated up the environment a little bit because of friction with the wheels on the ground or in the bearings, and it stirred up the air a little bit. Maybe it made a little bit of sound. All that energy dissipated into the environment. It's still there. We just don't really notice it anymore, and it's certainly not very useful to us anymore. Okay? So the energy starts off as gravitational potential, rolls down, becomes kinetic, and then dissipates into the environment, and we call that internal energy. It's the vibrations of molecules, right? The floor is made out of molecules, the car is made out of molecules, we're made out of, and so it just goes into the random motion of molecules all throughout the room. And the change is so slight that we don't even notice it, okay? But it's there, and it's not gone from the universe, but it certainly isn't useful to us anymore. So this is what we're going to do. Now, let me ask you this. If I make the ramp higher, so what's going to happen to the amount of energy of the car? What if the car's height was up here? What if the ramp was way up here? Well, I've got more energy in my system, don't you think? Right? So that when the car rolls down, it's going to be all that. It's got more gravitational potential energy, so therefore it has more kinetic energy, and therefore it's going to take more the friction and the air resistance. It's going to take it longer to make the car stop. Okay? So that's the energy interaction we're going to look at today. Stay awake, stay with me. Wake up. There you go. Okay, all right. It's all right. It's all right. I fell asleep in class all the time when I was, so it doesn't offend me. I'm just going to, have somebody stick you with a pencil or something. All right. So here is the question for the lab, and I want you to write this down. How does the height of the ramp affect how far your moon buggy will roll? So just write a sentence. Like, what do you think? And you can put in some detail in there if you want. Yes. Just copy down the question. Okay. So I want you to write a hypothesis. So talk to the people in your group, maybe write a hypothesis. Now, the thing I'm going to have you do next, before you do it in your notebooks, I want you to do it on a whiteboard. You're going to need two whiteboards today, one to use as a ramp and the other to use to prepare for this. You're going to, after I'm done explaining, I want you to write a procedure. List the materials you're going to use, and then write a step-by-step procedure, kind of like what we did with the power lab, okay? Most of my labs follow this basic layout, so get used to it. Step 1, 2, 3, 4, 5, what are the things that you're going to do to gather data so that you can answer this question? Now, I'm going to give you some hints. What I want you to do is you're going to, the materials you're going to use are your moon buggy, your ramp. It's going to be one of the whiteboards. And then I've got a long string that's marked that we're going to use to measure the distance that it rolls. Okay? And what I want you to do is pick at least 3 heights. Now, for example, you could pick 5 centimeters, 10 centimeters, 15 centimeters. Now, who has the car that rolls all the way across the room? Okay. You guys will probably need, or if your car really rolls a long ways, you're going to want to pick fairly small heights, like 5 centimeters, 10 centimeters, 15 centimeters. Now, if your car doesn't roll very far, okay, you can pick higher heights, like 10 centimeters, 20 centimeters, 30 centimeters, okay? But I want you to pick 3 different heights, and they don't have to be, every group doesn't have to do the same thing. They can be different heights, and I'd like it to be something like 5, 10, 15, or 8, 16, 24, 10, 20, 30, more than that, your whiteboards probably aren't going to work. And I want the height in centimeters. I want the distance traveled in meters. And I'd like it to the nearest tenth of a meter. Okay, so this is what your data table is going to look like. So so we'll stop right here. Okay. Eventually, what you're going to do with this data, these data here, is you're going to draw a graph where you're going to, our independent variable is the height at which we're releasing. Remember, in science, an independent variable is the variable that you, as the experimenter, decide. Okay, I decide my heights are going to be 5, 10, and 15, or 10, 20, and 30 centimeters. Okay. And then when you're done, you're going to write a conclusion, which is basically going to answer the question using your results. So you look at your results, and you're going to answer the question for the lab. So let me zoom out. So this will be your lab write-up. But again, the procedure and the data, I want you to do that on a whiteboard, and then collect your data on the whiteboard first. And then when you're happy with that, when your data is finished, you can have me come take a look at it, and I'll make sure everything is okay. And by the way, if you want to do more than 3 heights, you can. I just say at least 3 heights. And then draw and make a nice graph. And you have to increment this. Hey, some of you out there with sloppy handwriting, raise your hand if you've got sloppy handwriting and you're proud of it. Okay. All right. Use a ruler to draw these lines, because I am tired of seeing graphs that look like this. No, I will not allow that anymore. I want them to look good. Okay? This, we're dealing with data analysis. We have to be neat and precise if we're going to extract any meaning from the data. So anyway, I will let you get to work writing your procedure and writing up your data table. And then when this is done on your whiteboard, when you've written your procedure and your data table's ready on your whiteboard, let me know. You can go get your buggy car and start doing the experiment. Okay, go.